Good afternoon. This is Craig Moberg with UNEX Manufacturing. I just want to thank everyone for taking some time out of your busy afternoon and attending our Lean Principles webinar. Just a quick background on who I am. Currently, I'm the Flow Cell Product Manager here at UNEX. I've had a few different roles. Some of you may know me from when I was in inside sales, but I've been with UNEX now for a little over 4 years. My goal of this webinar today is really just to give you a comfort level when you're talking to some of your customers and to give you a basic understanding of what Lean is and how it applies to you. So when you have some talks with some of your decision makers, you'll just be able to entertain some conversations which will really put you in control and help you close a few more sales. So today, kind of what we're going to talk about, what Lean is. We'll then just touch on a brief history. We'll discuss the key principles, the 7 wastes of Lean. Some will tell you that there's 8. We'll just stick to the first 7 in this intro webinar. We'll then briefly get into cellular manufacturing and how it applies to you and UNEX, which then is really where we place some of our UNEX products, and then ultimately what you can do with the knowledge you gain from this webinar and how you can talk to some of your customers. So jumping right into it, we will really just let you know what Lean is. So by definition, Lean manufacturing is a system for providing the customer a defect-free product when they need it and when they want it in the quantity that they're looking for. So Lean means eliminating waste or trimming the fat, if you will. But this is just really giving you a more systematic approach to look at things we do on a daily basis, but how we can make those daily things go faster and easier. So what we'll do by becoming Lean is we're going to increase cash flow, and we're going to start making these products in the manufacturing realm basically better, faster, and cheaper. Those are 3 things you really just need to remember with Lean. So this is going to improve value to the customers. We're going to reach the customer's expectation. We're not just going to set the expectation on how we think it should be. And Lean is a culture. This is something that is done all the time, and it needs to be a buy-in on all levels. From the shop floor to the head executives. This is something that we all do on a daily basis. So we really want to just make sure we empower our employees, let them become part of the process and the solution, and not just tell them what to do, but even have them help us develop what a Lean system looks like. So like I just said, the goals of Lean is we're looking to eliminate waste. By taking out the non-value added items, we can make the product better and faster. We want to shorten the cycle times, which is where our faster comes in. We want to improve the quality. The quality must go up to how the customer expects it and at the price that they're willing to pay. So therefore, we need to bring the cost down, and then we're also able to manage the inventory effectively. So again, you see the better, faster, cheaper. When we talk about managing inventory, in a perfect world, there really would be no inventory and everything would be just in time, but that really just becomes unrealistic. So historically, we've all heard of Eli Whitney, basically for the cotton gin, which is what he was most famous for. But really, when he started developing firearms and muskets, he worked with the interchangeable parts, where he could use some of the same machinery, but change some of the tooling within that machinery to develop different items. So that was early Lean. Then we got into Frederick Taylor, which worked with some standardizing and time study. Gilbreth was also a time study guy and a motion study, where he dealt with some process charts. And then, the more popular lean would be Henry Ford with the American Assembly Line, and going mass production with automobiles. That was 1910, where they went from building a car in 12 hours, cut down all the way to 2.5 hours. So there you can see the lean process really coming along. Deming did a lot of lean studies. He took some of Ford's work, but the most popular lean would have to be the Toyota production system in the Toyota family, where they took their very limited resources and made their processes super lean to compete with the American car companies. So lean really is the way to get as much value as possible out of limited resources. So here's a picture just to show, Henry Ford in the first assembly line in 1913 in Michigan. Here's where he moved on with the Model T. I went from building a car in 12 hours down to 2 hours and 30 minutes with one option. Today cars take about 17 to 18 hours. However, when it gets to the end of the assembly line, they're able to roll off a car every 55 seconds. So going from one single option on a Model T to multiple trim levels here today on modern cars. So if we dive into the lean principles, value. Value is what the customer is looking for. The value stream, pretty much any part of the process as a product's made, all the way from suppliers to the end product. We're looking to get that one-piece flow, keep the product moving. Pull, getting the product or information when it's demanded. And then by taking those first 4 lean principles, we're able to get to perfection, which is what we're all striving for in a lean process. So what is value? Like you just mentioned, value is defined, by the customer. They want their product when they want it and in what quantity they want it, as fast as they can get it. So we're really just looking to meet the customer's expectations at the price point that they're willing to pay. They're only looking for the features that they want to pay for. They don't want anything extra or any non-value added pieces to that product. In lean thinking versus traditional, costing, traditional costs, we take the price for our material or goods, and then we think of what kind of margin we're looking to make, and then that becomes the price that we're going to charge the customer. Completely different than lean thinking, where lean, the customer really tells us what they're willing to pay, and then we have to figure out how to reduce our costs to meet the price that the customer is willing to pay. So no real relationship between cost and price in the traditional thinking, where the company just picks the price that they want to make and they just increase the margin. Lean thinking is more of a top-down approach where the customer determines the price. So the value stream. All steps and process involved in going from raw materials to the final product. This could be all the way from the first sales call, doing some configuring or engineering, purchasing the parts or raw materials to make the final product. Then it gets scheduled and goes into production, gets handled around the factory, then gets put on a truck, shipped out to the customer, and billed. And that really is the entire process from start to finish. So when looking at that process, we need to see how we can eliminate anything that's non-value added. So flow, keep the product or process flowing fast so your customers are served better with shorter lead times and a better quality of the product. They want it, free of defects. We need to make our manufacturing facilities more flexible with less inventory. The faster a product flows, the cheaper the product is. The longer it sits around and takes up space, the greater risks of defects and the increase of cost. So cost in a lean process is really determined by the flow. So pull, making what's needed when it's needed. Think of, when we want something, we get on the computer, we go ahead and put our order, when we need it. The customer then, or we're the customer, and then next thing you know, the product is shipped to us when we want it. You take a company like Amazon, for example, they feel that they make a lot more money when they use their push system or forecast what they think you're going to buy. So they're going to offer maybe a small discount for them to continue just pushing items to you even when you don't ask for them. So the push is really based on approximations or anticipated usage, which could turn into high inventory. In the manufacturing realm, if we just kept making product when it's not needed, it's going to start to create large lots or large batches and pile up. If there's ever a defect in any of those products, you're just going to keep building more and more defective products, which becomes a really large waste. Back to auto manufacturing, a company like General Motors keeps about 9 months of inventory, which seems like a lot. If you look at Toyota, which we know the Toyota production system, Toyota actually only keeps 3 weeks of inventory with their automobiles. They keep a week in transit, a week on the showroom floor, and then a week of inventory in the factory to be shipped out. So you can see two different schools of thought. Toyota carries a lot less inventory, which in turn carries a lot less cost. So then perfection, which is really just achieved through the first 4 steps. With what I said in the very beginning, lean is a continuous process. It is not a quick fix or flavor of the month. You need to strive for continuous improvement all the time, and create a learning organization where your employees are constantly learning and being part of the process to make the products better. So those are your first 5 principles of lean, and then we can jump into the 7 deadly wastes. If you look going vertically on the left side of the slide, you can see that in blue it says Tim Wood, which is the acronym for the 7 deadly wastes, which are transportation, inventory, motion, waiting, overproduction, overprocessing, and defects. So jumping right in. Transportation is material movement that does not add any value. We need to keep things close together, because really all you're doing is adding a cost when the product has to be moved. So excess transportation is poor layouts. If your facility has stations which are placed all over and nothing's close and you're constantly moving material from one to the other, it's really just wasted movement. And all that comes with a cost, whether it's putting them on a cart, putting them on a fork truck, putting them anywhere, but someone has to control that. So large batch sizes create some excess transportation. Working faster than the customer demand. We talk about pull and the principles. If we're just pushing product versus pulling it, we're working faster than the customer demand. And then if you have multiple storage locations, it's just going to take more time to get it to where it needs to be. So inventory, mentioned it a bit earlier. I think it's probably one of the biggest wastes, because really now you just have products sitting around and taking up space, which comes at a really high cost. You think your facility and real estate costs. So inventory really is a big one. Like I said, in a perfect world, you'd have no inventory and everything would be just in time. With your inventory, money's already put out with your raw materials, and now it's just sitting on the floor. Also, inventory is a big hidden waste of defects. If you keep producing product that's not needed and it's just sitting there with no demand, you really could be covering up some defects. So to prevent it, take a look at your production process, create a smoother flow, go to smaller batch sizes, just make what's needed. Make sure you're always using the first in, first out principle. So that way you're always taking, everything keeps flowing through and you're not just, taking the first that was last put in. And then reduce changeover time. You see SMED in parentheses, which stands for a single minute exchange of die. So you think of changing tooling parts or changing punches. Could be a really long time associated with this. So we really want to cut down on those. And then make sure that your workers adhere to their procedures and they do the process in the most time conducive manner. Motion. So now the first one we said was transportation. You may say motion sounds very similar. Motion is the movement within a process versus the movement between processes. So think of if we're at a work cell and the operator is constantly reaching too far for the product or needing to reorient their product or constantly pulling or twisting or just basically everything's not right in front of them in their kind of ergonomic sweet spot. So to reduce motion, we can work on workstation layouts where here at UNEX we make customizable flow cells, which are workstations. We can make their methods to the point where everything's always within reach and work on their workspace layouts, like a U-shaped cell where everything kind of works around and keeps things close. So the next waste is waiting. Basically any idle time between two independent processes that are not synchronized. One person finishes, the next one's not ready for the material, or the other person finished first, pushed their material down the line, and now they're waiting for the material to come before them. So some of the causes of waiting, it's caused by machines, products, and people, and info that doesn't flow to the workers. So like I said, if the previous process runs a little overtime, the delivery from the process before fails to get there on time, unreliable people, unreliable machines, no coordination, not having the right batch size. So one process could be making a larger batch, the next process could be making a smaller, and they're not in sequence. So really just looking at times between jobs to keep that one piece flow. Overproduction, you have two types. Producing something before it's needed, or producing too much of a product, which results in work in progress or surplus, or wasted inventory. People will say, we've always done it that way. They produce a product just hoping that there's a demand for it. Large batches, they create large batches because they say that it takes too long to change over a machine, where we mentioned SMED. If they can reduce changeover time, they can work in the correct batch size. Another reason is they may not trust their supplier, or they don't trust their internal process. So by keeping some of these things balanced, they can cut down on overproduction. Overprocessing. Now here's one that a customer does not want to pay for because it's a non-value add. Putting more into the product than is valued by the customer. And this could be something like where they paint an unseen area of the product if they don't need it. Super tight tolerances. A product gets machined down to a really tight tolerance where it doesn't have to have that much attention to detail. Cleaning and polishing beyond the desired level. There's no reason, to make something better than it needs to be. It's just going to create an added cost. So do it to the level that's valued and necessary. And overprocessing can be caused, by no standardization. One work cell might do do the job differently than the guy next to him just because nobody ever told them how it should be done, or they never were part of the process in creating the standardization of work. So make sure the specifications and standards are laid out to the leanest method. And lastly, we have defects. Waste of a correction or doing work over. I think we've all heard of, a boss at one point say that, nobody has enough time to do it right the first time, but we all have plenty of time to do it right the second time. So make sure that you follow the work order and don't create any defects. Defects are caused by unclear operating procedures or specs, inadequate training, lack of skills, incapable processes, incapable suppliers. You might not use the material that you're used to getting and have to go to another supplier, and now it's a little bit different than the way it's usually done. The operator might make some mistakes. You could have too much stock, which was hiding the defects, in your inventory. And then excess transportation. You never know how it's going to arrive. So if you can cut down on transportation, you can cut down on some of your defects. So cellular manufacturing. This really now is where UNEX comes into lean, and where we're trying to put you as our customer, our distributor, in a spot where you can have conversations with the customer and feel comfortable. So cellular manufacturing is a lean method of producing similar products using cells or groups of team members, workstations, or equipment to facilitate operations by eliminating setup, unneeded costs between the operations. So the cells might be designed for a specific process part or complete product. So with our flow cell, which you see there, the workstation on the right of the slide, can be used for line-side storage, assembly. We're going to keep minimal inventory, but it's going to flow to the operator, and they're going to have that first in, first out inventory to minimize inventory, minimize defects, and have just enough for when they need it. So in the sub-assembly area, we could be working on some small parts which are fed to the line for the final assembly, where we're able to use our flow cell, whether just to store some products or actually kit products or build some products. We can really customize those units for anything the customer demands. Here you see some flow cell units in the back, which are providing some parts to the sub-assembly line. This currently is a seat that is being made at Adient in West Point, Georgia. As these seats roll off this sub-assembly line, they're actually in a Kia plant, also in West Point, Georgia. And from the time they roll off the assembly line here at Adient, they are in a vehicle in about 90 minutes. So earlier when we talk about reliable and capable suppliers, you need to make sure that not only within your own facility are your processes in time, but to make sure that your processes and your supplier is within the time you need to deliver those parts. So here you just see some different parts being delivered to the line, and where our units come in today is they're very flexible. We're able to meet the demands of today's automobiles, which have plenty of different trim levels. Some cars all have different options, whether they want cloth seats, leather seats, cruise control, no cruise control, cloth floor mats, or all weather mats. We really are able to provide a product that's going to deliver these different trim levels to the line and keep the car moving based on the demand. So as the car moves down the line, we're able to put the trim levels or the options into it based on our storage that we provide. So where UNEX and you as the distributor come in, you're able to give the customer options with our flow cells, which present the parts to the operator. They save space. They're going to get them that good flow. We can create great ergonomics by having the parts being presented in those ergonomic sweet spots and places where they're not going to have to do much reaching, bending, or even moving. Everything's right in front of them. So that being said, here you have a person putting together some small parts which are being delivered. We're able to hang a toolbar overhead, which you can see that her air tool is right in an ergonomic space and she can reach every time. By having all these parts put in place, we're able to reduce errors, which would turn into defects. If we reduce the wasted movement, there's motion which is occurring within her process. We're able to cut down on cycle time, and then we're able to cut down on some of the labor by keeping everything right in front of her, so no more overprocessing or no extra overprocessing. So I've mentioned flow cell a few times here within this webinar, just to give you a little more background on what flow cell is. This is our structure that we make here at UNEX, and we're able to put all of our flow products within this structure. The best way I like to think of it is it's a large erector set. If you can think of it, we can come up with a solution. It's a 1 3/4 inch heavy gauge square tube. Most flow cell units could be put together within under 30 minutes just by using a 9/16 wrench. So what we do is we get all parts and tracks which are angled to the operator to decrease reaching and improve their ergonomics. And all of our structure can be reconfigured if the application changes, per the customer in the future. So, like I said, all of our flow products fit within our structure. In the top left, you see we have some standard span track lanes. We have some more heavy duty in the top right, and then below we offer a standard wheel bed product, which is able to, which has a rated capacity of about 50 pounds per square foot. And down the bottom right, we have a heavier duty steel skate wheel bed. So all our flow cells, you're able to put in up to 1,000 pounds per level. And the only restriction would be is if we put these units on casters, we become restricted to 3,000 pounds for the total unit, just because each individual caster is rated at about 750 pounds. But like I said, it's really just a large erector set for the manufacturing floor. All of our posts run on 6-inch increments, all the way from 3 feet to 7 feet. All of our beams go from 1 foot to 8 feet, and the posts are punched on 1-inch centers. So as you see, here's a unit that's great for an assembly line where the operator can put parts together and then turn around and put them onto the moving line. Here's just some ideas. However, you're not limited to any of these options. If you do have any ideas, always feel free to reach out to whether it be myself or our inside sales team, and we can work with our engineering department and configure a unit that meets your customer's needs. Here at UNEX, we provide you the engineered drawing. We can usually turn quotes and drawings over within 24 hours. So we have really quick turnaround there. We'll soon have some 3D drawings. Here's just a quick comparison of one of our solutions on the left versus the pipe and joint competition that we constantly go against. The advantages to UNEX is that we're a much more robust structure, but if you look at what we create on the left versus what they're creating on the right, we use a lot less parts, and we're able to put these units together in about 30 minutes. So we're going to engineer you a solution based on your customer's needs versus just sending you a huge kit of pipe and joint and let you try to figure out how to put it together. So when comparing to the pipe and joint, we're about 60% less parts. Our installation is fast and easy, and we are extremely durable. So really the main goal for me of this webinar was to hope that when you're out on the road or you're trying to sell some solutions to your customers, you're doing exactly that. You're selling solutions and helping them and giving them the benefits versus just trying to say, here's a product that we can sell you. So some of the people you may talk to would be your, a continuous improvement manager, a lean manufacturing engineer, a lean process manager, a quality manager. These are the decision makers. So I hope that with some basic understanding, whether it be key terms of lean or some of the basic principles, you'll now be able to speak to some of these decision makers and close the sales that you're looking for. From my experience, just by having some of these terms and having a basic comfort level with the basics, you'll be able to entertain some more conversations than you may have been comfortable with before. So you're able to sell on overall benefits and concepts, not just on products that you did before. So know that you really can never be 100% lean, but you can always strive to be better. No matter how lean you are in certain areas, there might always be some bottlenecks or constraints, but you can always take a stronger look at those and see how maybe one of our systems or some basic lean principles might help that out. So with a little feedback, I'm hoping to keep these webinars going. So I'd love to hear from everyone who attended today. In the following slide here's my information. So I always want to help your business grow, and I hope that I can offer you some extra knowledge which can do that. I'm always available with my contact information, so please take down my email and phone number. If you have any questions, feel free to reach out. We'd be happy to offer some solutions. Part of my role is I've been on a bunch of calls with our customers, whether it be on site or on the phone. If you have any sales meeting presentations that I could attend and speak to your sales team, I'd be happy to do that. But overall, I just want to thank everyone for taking the time out of your busy day to come hear what we have to say at UNEX, and we hope to just give you some more knowledge and make all of our distributors a little bit better. So have a great day, and I look forward to talking to you in the next one. Thanks.